So I'm showing video here of Tim Thornton. He is the owner of Tactical Electronics. It's based out of Tulsa, Oklahoma. And he and his team are really the brains behind the jet ski, which there's a shot of the jet ski right there. So I'm going to turn this over to Tim Thornton, and he's going to give a bit of an overview of the jet ski and maybe highlight some of its important capabilities, and then give a brief overview of what we're going to do on the test today, so everybody on the Zoom calls know, and he's going to speak loudly enough so everybody out here can hear him, and hopefully we got a good audio, guys. Kevin?
I can hear you.
Yep. Okay. All right. So over to Tim.
No,
I'm kidding. All right. Everybody hear me okay? I appreciate all you coming out. Sorry, we've got some glitches here. I appreciate your patience. What we've got here, I am the owner and CEO, I told you, and the lead scientist for our Nomad project, what we're calling it. Nomad is the vessel. It's a remote sensing platform that we have built on kind of the basis of a jet ski. Jet ski is a personal watercraft that's been proven itself for a lot of years. There's been a lot of tech that's been developed around the personal watercraft. The engine is a Rotax 900, which they use in personal 4x4, side-by-side, razors. They're used in snowmobiles and also personal watercraft. So there's a lot of easy ways to get parts replaceable in the field. This is a closed loop cooling system. We are not using any of the water, salt water, to cool the engine. It's a closed loop cooling system, which makes us another attractive platform for our ocean going applications. We started with the ski and we stripped everything out. The only thing that we're really using, we have a donor ski, we put the motor in it, and we use the hull. Everything else is gone. Once the motor and the hull are put together, we start adding all of the electronic packages. One of the more prominent ones, as you can see, is the Garmin radar dome at the top. You can see 200 miles out. We can see birds at about 70 miles. If anyone's familiar with the Garmin radar package, it's got everything you can possibly imagine. Collision avoidance. You see a floating tire at about 10 feet. We have an AIS radio, so we're able to see other traffic, floating traffic that's in the lanes or close to us. We also have an AIS signal that transmits vessels in the field. Our communication package, we've got 3 different radios. Right now we're using our long-range VHF or UHF radio. We're transmitting from the ski to the mast that you see on top of that trailer. We have look at the little white panel on the front patch there. That is a Starlink dish. We started this program with the Starlink about 2 years ago when they just kind of come onto the market. So we had to take that Starlink apart and kind of modified it and made our own little version of the Starlink. They now have a more advanced marine version that doesn't have the motors. It allows you to operate in motion. The plans have come way down in price. We're very happy with the Starlink. We've had awesome luck with the connectivity of the Starlink. We also have a cellular engine. There's 4 cellular cards in there. So if you're operating close to a coastline, you can reach out, send the signal over cellular. So the plan is there's a local operator that launches it. We use our UHF radio to get it out on the ocean, and then whether cellular or satellite is available, and get it back to the command center. The command center that we brought with us is this trailer. The trailer actually is the transport system for the ski. The ski goes onto the trailer behind that truck. Those all get loaded into the trailer. We're going to go over and look at the trailer here in a few minutes. But once the ski is out of there, that becomes the command center. There is heat, there's AC, there's a generator. We've got 4 different monitors that display all of the dashboards for the Nomad. We can put 16 cameras. We only have 8 of them installed in this particular version. We've got the Garmin suite so that you've got all the remote Garmin capabilities. I mentioned the radar. There's a full sonar package. 2 different sonar heads on here. If you're familiar with the Panoptics, we can scan a river or ocean bed and create a 3D map where you could be 10 miles long, and you can zoom in, zoom out, spin it around, 3D environment to map the ocean floor. The system that we have mounted on this particular remote sensing platform is the herd and burn. There are 2 pods on each side of the ski. You can see they say danger. They've got yellow MAP gas tanks strapped on top. We kept the MAP gas tanks to external, so if we had any leaks, we would just be filling the hull up with flammable gas. What you're going to see today, the demo we're going to do is this particular vessel is made to, a spill's been discovered. We're going to go out to the spill. We're going to visualize the spill. There's a drone that's going to be up in the air transmitting live images down. I'll be driving the ski from the video that's fed from the drone. It's like a video game. You're looking straight down. I can see the spill. I can see the ski, and it's easy to navigate around the spill versus me trying to do it on a horizontal platform. I just have no depth perception there. So I'm going to drive around the spill. We're going to identify it. We're going to then squirt further. We'll drop some further all the way around the spill. Once we do that, they're going to drop the frame, which releases the oil from the frame. It'll start to interact with the material. The herder is going to push it into we hope to see maybe 3 to 5 millimeters of stacking of the oil. Once it becomes volatile at 5 millimeters, I'm going to drive back around and we're going to open up one of these pods and we're going to shoot gel gasoline out of the pod and catch the spill on fire. If you guys saw the video in the back of the classroom today, that's what we hope to see at the end of this exercise here. Once we do that, we're going to let that burn. It just takes a few minutes. We'll bring the ski back up. We're going to pull it out of the water. We're going to do a quick visual check of any oil, residual oil that's on there, do a wipe down. Then we'll pull the ski up where you see the truck sitting down. And I'll do a little closer walkthrough. We'll open everything up so you guys can look inside and see what it's made of. And then we'll also do a walkthrough of the trailer. We can see what the command center looks like. So are there any simple questions maybe right now, or can we start the exercise? I think you want to give them where the keep in and keep out zones are. I will tell you that the best view is on the big monitor that we've got set up. There's really not much to see here until the fire gets going, and just turn around and you'll see it. It's huge. But the video that streams from the drone to that monitor is probably the best place to see.
Tim is going to be headed over to the tent and we'll walk you through the video display during the burn and the process. And I think we're ready to go ahead and set up for our first test of the day.
Yeah, I think we can send the guys out with the crew.
Yeah,
All right, I'm going to unshare. Well, I don't know how to do that. So we're going to unshare this screen and we're going to reshare the screen that's coming from the demonstration.
There's screens here under the tent as well as screens in the back of that van with the canopy there. You're welcome to be anywhere in the front.
Okay, this is Kevin Abnett from Poker Flat. So right now you're just looking down at the test basin. You can see in the middle of that is the square where we dump the oil. And so it'll take a few minutes to get the drone in the air, and we can start sharing that footage.
All right, Tim Nedwood again here. I'm back on the kind of the command center computer where we're going to show the video. You can see this video is from is that an antenna?
It's a tower. Yeah, it's on a radio antenna.
Yeah,
We're
so
about 75 feet in the air.
Yeah, so that camera gives a kind of a good overview of the test basin. You can see this test basin is 100 meters by 100 meters, I believe, roughly. And you can see the jet ski sitting there. It's not on right now, it's just sitting. And then in the middle of that test basin, you can see an 18-foot by 18-foot release frame. So as Tim said, and a test will happen, and pretty soon you're going to see some guys from Shadow, an oil spill response organization here in Canada, in Alaska. They are going to take 3 5-gallon buckets out to the test frame, and they're going to drop the oil in the test frame because we need to keep the oil contained. We might not need to do that today because you can see we're flat calm. It's really good weather. We don't really need flat calm. We don't need calm. Herders and burning can happen in high winds. It's just in the closest to this tank. We want to be very careful to do the in situ burn part with the oil away from the walls of the basin, because the basin has this geotextile impermeable barrier under it, and that barrier cannot take the heat from the burn. So we want to do the burn in the middle of the tank. So we have the test frame in the middle of the tank, so we can kind of keep the oil contained until we start the test and avoid wind blowing the burning oil slick over to the side of the tank. Right. So well, it's going to take about, I don't know, 10 or 15 minutes to get the oil into the tank. So I'm gonna kind of shut up and just be patient, and I'll come back on when we're ready to go. You can right now, you can see we have a little John boat that the guys use. The test basin, by the way, is only 26 inches deep. So you can see the guys are actually just walking on the bottom of the test basin and carrying the 10 gallons of oil. The oil is Alaska North Slope oil. It's fresh oil, so you'll see it's very burnable. And so let's give those guys a few minutes to drop the oil into that test frame, and then we'll fire up the spray herder. You'll see the jet ski make a loop around the test frame, spray the herder. We're leaving the test frame up, which is artificial, but the goal is not to test herders. It's to make sure we test the capabilities of the jet ski. So we're going to spray the herder with the frame up, to make sure that we keep the oil from going to the side of the tank as much as possible. So give us about 10 or 15 minutes, and we'll start the herding and burning.
Kevin, you've got a question in the chat.
Thank you.
Tom Parkerton wanted to know what oil was being tested.
All right, we're back on. I went through the chat and there's a couple of questions. I think nothing that's too technical here, but the oil we're using, I think I mentioned it, but it's Alaska North Slope oil. We're in Alaska, so that's the most convenient oil. And it's artificial because we haven't weathered it. But as I said, our goal here is not to test whether or not we can burn oil. We know we can do that. We're testing the capabilities of the jet ski as well. So this is ANS crude oil that's very volatile and is going to be very burnable, as you'll see.
Can folks who aren't presenting mute their mics, please?
So folks, the weather here is really nice. It's about 70 degrees out, light clouds, and winds are almost calm. So that's almost ideal conditions for what we're doing today. We're really happy to have these conditions.
Probably better for you. Gotta switch it to. Oh, well, I'm not connected to that. Do it on yours. Do you have it? I'll forward it to you. They basically outfitted a jet ski that can.
Okay, I'm gonna start showing the drone video momentarily here. It's just about ready to launch.
Got it? Now turn it sideways. But you better hear it. There you go. Can hear it. You need to mute it or unmute it, or maybe they're not talking. They said they just
All
got
right,
put in
all right,
you
online
go.
team. Where are we getting that back up? So somebody has their mic on or something, so double check that, everybody. All right, we're back. So the oil has been placed in a test frame. You can see the video now. This is from a drone that we have that's going to be the monitoring drone. So it's going to go up and get a view over the top of the test frame we just showed you. You can see it is being launched right now. So it's being maneuvered over to the tank, and pretty soon you should see the test. There, the test frame's coming in to the view there. So now that drone is going to stay over the top. You can see the oil is in the test frame, and Tim Thornton is going to fire up the ROSV, remotely operated surface vehicle. That is going to, the first maneuver here will be to spray the herder around the perimeter of that frame. I believe we're getting ready to do that. Getting close. So in the next minute or so.
Start doing loops.
Okay, so we're gonna, tell me when you go herder on, just say. You gonna run the herder? Tell me when the herder's on. So the jet ski is gonna make circles around the, it's gonna run a couple circles around to get the lay of the land, and then we'll start the herder and proceed with the test. So this is really the beginning of the test.
Tim, we'll tell you when we've gone long enough. I can start at 30. Or are you saying it's ready?
We're ready now, yeah.
We're ready.
Whenever you guys are ready, spray herder.
Mark wherever you start. It's 3 o'clock.
So the herder comes, you can see the little panel on the, what is that, the starboard side? And you can, if you have a high enough resolution, you can see the herder coming out, and it's just dribbling straight into the water at roughly 5 millimeters a minute, I believe. And so Tim is maneuvering the boat carefully around.
Yep.
Those 2 wires you see there are submerged, and those are the wires that we use to pull the test frame from the side to release the oil. We're going to make 1 loop around here. You can see the herder still being sprayed out. And once the loops made,
5 o'clock.
yeah, 5 o'clock, or you can go to 6 o'clock.
ExxonMobil.
And you can't see it, but the herder is doing its thing. In fact, if you look at the sheen that came out on the right of the test frame, you can see the herding action of that sheen, which is what it's supposed to do. So let's
Drop the
pull it.
Jessica, ready to pull.
So we're going to drop the test frame. You'll see that. That's going to disturb the herder a little bit. We have perfect weather today. There's no wind like at all.
Frame is dropped.
Did it drop?
Yes.
So the frame is dropped. You can see the oil starting to move out.
Yeah.
And you can see the herding action now, even on the right side of the test frame. I will say the herding action is not as dramatic as it would be if we did a pan test. And part of the reason is because the tank has had 3 or 4 days worth of surfactant put in it. So it's surface tension is somewhat compromised compared to what it would be if we were out in the middle of the Atlantic or Gulf of Mexico, or it would be different. But you can see the herding action is happening. The slick is contracting. We're going to give it about 2 minutes to for the herder to do its thing, and then Tim and the team are going to come back in, and you can see the door open on the jet ski on the starboard side. That door is also has the nozzle for the gelled gasoline. So this is a flame throwing jet ski. The only project I work on that my teenage sons are actually interested in is this one. And so the flame throwing jet ski is going to run around on the kind of, I guess there is no really upwind edge here, but it's going to spray from about, I don't know, 15 feet away at least is about the arc of the gel gasoline, and we're going to ignite. And but you can still see the herding action. It's not fast, but it is happening. We've been letting the slick get to about half of its size, because then we know that it's more than 2 millimeters thick. And the rule of thumb is an oil slick needs to be at least 2 millimeters thick to ignite and burn. So let's give it a little bit more time. Maybe 60 more seconds.
Hey, you guys, look. That's a spill.
Hey, we still have somebody's microphones on.
Oh, it's in the ocean?
People's microphones on.
Alicia, can you turn off your mic, please?
You can mute people too. If you want to.
Oh, that's right.
Okay, I got it.
Yeah, it looks like they did.
Whatever you think, Tim.
Another loops, I think everybody's.
Yeah, I think as soon as you can, let's fire, because we don't want this.
Go one more round.
Right. Okay, ready when you are.
All right, so he's moving the jet ski up, and we're gonna fire the flamethrower. This is gelled gasoline that's gonna come out here any second. There goes. And you can see how volatile that oil is because the flame front faster than, there you go, that's good. And you know, if we can, you see these, do you see these portions over here, Tim, at 5 o'clock? I don't know if you can hear it here, but it's pretty dramatic. It's pretty dramatic visually, and we can hear that burn. It's been lasting about 60 seconds or so of intense burn, which means we're probably losing 2 to 3 millimeters thickness, which is probably 70 or more percent burn efficiency. And once the oil burns off all the volatiles, the burn stops. What's still burning might be residual gelled gasoline, actually, because it burns longer than the crude oil will. And
Switch to other
you
camera.
want to go to that?
Yeah. So at this point, you can see it's pretty much all burned off. And,
So we've done, this is test 5, this is test 6 this week. Yesterday was our best day, and you know, something like this, it's complicated. It takes us a while to get to, you know, get everyone kind of trained up on what we're doing. But yesterday, we think at the most we had 2 to 3 gallons of kind of oily water that was picked up at the end. My guess is that's got a big percentage of water. We started with 10 gallons. So I'd suggest that for this, even this kind of burn here, we're getting 70–80% burn efficiency, and which is pretty good. And if we have questions, I'm happy to try to answer questions while we're waiting for things to cool down and pull the jet ski out of the water.
You've got a couple more questions in the chat.
I'm missing the questions. You see it? Let's see. Let's look at the chat. Remind me how much oil was put in the water. Okay, 2. So 10 gallons to start with is the original oil. Some of it might evaporate pretty quickly because it's fresh oil. And how do you determine how much residual is left? All right, so that's if so we'll evaluate the video, and there's some rules of thumb on how much, the rule of thumb is 2.5 millimeters of burn. So the burn efficiency is based on how thick the oil is, and it burns down at about 2.5 millimeters per minute is the rule of thumb. So we will look at the video after we're done, and we'll determine, we know how much volume we put out, and we'll determine how much time we had the intense burn, and that will give us 2.5 millimeters a minute information based on the rule of thumb burn rate, and then we will attempt to estimate how much area was under that intense burn, and then we can get based on the 2.5 millimeters a minute, we can get an idea of how much oil was burned. In the past, we've done more sophisticated things, but the goal of this is not to test herders and burning. The goal is to test the operational ability of the jet ski. But in the past, we've gone out and collected the oil with the residual oil with sorbent pads. Then we let the water evaporate off those absorbent pads and weigh the pads before and after, and get an idea of how much oil was actually collected after a test was over. We would do that if we were in the, if the project here was designed to test herders and burning, but we are not doing that. So we'll make the estimate with the camera video, and we collect a residual, and we can kind of get a very qualitative estimate. And as I said, I think the response team that collected the oil after each test believe there was 2 to 3 gallons of uh-oh, is that you? It's not you.
No,
That was
the drone.
The drone. So 2 to 3 gallons of residual oil came out of the tank on absorbent pads when we were done. As I said, I think that's got a lot of water in it, but we don't know how much water was in that. So my estimates is 70-80% burn efficiency based on what we've seen so far. I do think these burns are more efficient than the rule of thumb burn, because those are based on very large pool fires, and large pool fires have a challenge getting oxygen into the center of it. So the efficiency in the middle is challenged, but our burns are tiny. And so I think they're more efficient. I would guess we're burning at 3 millimeters a minute, and maybe even more than that. All right, I got another question.
So does the residual sink?
Our residual does not sink. So that's very oil dependent, and this ANS oil is to begin with, but even the residue doesn't sink. If somebody didn't collect it, it's going to be more dense than it was when it went in. The residue is, and so over time it might react with sediments and things like that in the water column, and sink faster than fresh oil might sink. But it has been easily collected because it stays on the surface. What is the length of time?
Okay, yeah. So what is the length of time that this can operate in the ocean without being recovered?
So it depends. It has 3 times the fuel capacity, because we've had 2 additional auxiliary fuel tanks. And so if we were running it at full throttle, it would go through even those tanks pretty quickly. But we believe it's somewhat, if we're just idling around, it could probably have 30 hours of operations time. If we're doing kind of intense motoring around, it might have, down to 12 hours, but somewhere in that range. But we haven't completely exhausted the ability to add auxiliary fuel inside. There's still space inside the jet ski for another few gallons. Exactly how much, we don't know. So we think it can be something that can be, especially the remote sensing tool, once it gets out on a sea somewhere, it can be staying in the vicinity, in the arena of a spill for greater than 12 hours, maybe up to 30 hours.
Okay. Are there any plans to test this in forming or broken ice?
So there's no plans for this project to do it, because we're not a Arctic research project so much. But I will say that the jet ski is made out of this polymer. I think it's polyethylene. That is very robust, and so you can go online and you can look up these YouTube videos of these guys who have the same type of jet ski, the commercial jet ski platform that we use, and they do these trips down rivers that have broken ice floes in them, And so what they'll do is they'll take their jet ski and speed up in the lead between the ice flows and get some speed. And then the nose will hit the front end of that ice flow. And then the jet ski will skid across the ice flow to the other side. And they'll go back in the water, hit the throttle again and find the next ice flow. And so it is capable of doing that kind of thing in a river. You know, Arctic or marine ice in the Arctic you wouldn't be doing that on marine ice because it wouldn't be so smooth. But it is able to withstand punishment because of the holes. It's not a fiberglass hole. It's kind of jet skis that I grew up with when I was a kid. If you did that on a jet ski like that was made out of fiberglass, it would crack and sink. But the hole is take a big pounding. You could hit it with a bat. In fact, we ran over a piece of it with a car accidentally with a truck the other day, and you couldn't tell there's anything wrong with it, that it was run over with a car. So I think it does have those kind of remote capabilities. You know, it's not going to do anything in 100% ice cover, but it can maneuver its way between broken ice leads and do things without probably having any problems. I believe the jet ski hull material is this kind of high density polyethylene. I think. Don't hold me to that though. It's the hull is the same material that you're like my a couple of my trash cans at least. I can run over my trash cans with my car and they will bounce right back. So it's the same kind of polymer that is used in that kind of trash can. So you can bend them all over the place and they bounce right back. Are we getting there? Yeah.
Okay, so later on, just keep coming with your questions. But after we're kind of, as we're wrapping up here, I will show the YouTube video of some earlier tests that we have done. Not this tests, but earlier ones. I think it's about a 3-minute YouTube video.
Yeah, no, that'd be great. Okay, so right now the jet ski's pulled out of the water and it's back on its trailer. So we're gonna take a couple minutes here and then restart the video feed from a phone camera, and we're gonna turn it back over to a little more detailed discussion of the jet ski, and the camera can be right up on it. And you can stay here and watch the chat.
Yeah, I'll do that.
And we'll try to answer questions from the chat, and then we have a big audience here, about 20 people, and we'll be answering questions from them. So I think you'll be able to hear those questions and answers from the phone. All right, so give us a couple minutes.
Pretty cool.
So right now we have a team going in there to clean up the residuals so that we have a nice clean test basin, and it's going to be ready for future tests.
Okay.
Just be a few more minutes as we get ready for the kind of the deep dive on the jet ski and all of its capabilities. It's got quite a lot of technical wizardry packed into a small space.
Yeah, because just the right up. I agree. I will tell you, I think so. Try that. This was a good test because we put it from Tulsa all the way to here, 3,500 miles through Canada and everything on the road, put this whole thing on the road. So we got a good test, nothing came apart.
So I need to pull up your camera.
I don't think so. Doesn't it pull it up from Zoom? It's an iPhone.
Are we about to walk through?
Again.
Tim, we're all hearing your audio feed.
Big screen. Didn't ask for camera permission.
Maybe I did something wrong.
That's it. No, it's looking back here.
Yeah, that's.
Sorry. Video.
Kevin,
Video was not.
Kevin,
on.
you need to.
Video was not on.
You need to
There you go.
share.
Start video. Now it should access the camera. So wait till you see you. There you go.
Okay.
Now
I'm
you
gonna
should be able to swap.
share screen, right?
Yep. I think that's right. I see you.
Oh, you saw,
Yeah. Over there. Yeah.
you
You're
see
on the-
me?
We're full screen on the.
So how do I? So I don't want to show me. We want to turn the camera around here, right?
Yep.
Okay, everybody. So we're back. Are you ready? So we'll go over there and do more show and tell. So we had a, you could see it was a very successful burn. Everything worked great. The commander, the captain of the boat, is getting better at maneuvering it around it. And so now we're going to do a little show and tell of the jet ski with it out of the water. So you can see the ROSV is on its trailer. And there it is. And we're going to ask participants if they have any questions. And Tim might give a little spiel about it more close up before we do. And he's going to open up the compartment so we can look inside. Yeah.
You want to see a little bit closer up on the jet ski?
This is
Like that?
that's the nozzle.
That's
You can see it's just an off-the-shelf spark plug to ignite the propane. Here's the propane canister, and that's the igniter. There's the nozzle for the,
So it's got a total
hard
separate.
to see, the nozzle for the propane, and then this tube is what the gel gasoline comes out of. So the process here is ignite the propane. That is the ignition source for the gel gasoline that flows through the flame of propane to ignite it.
It almost break your arm. It's amazing. But it's a high tech. Yeah. So it's a good brand. Yeah. We
But Tim,
never
I'm
had any
gonna-
trouble with it, and it's.
I'm gonna turn it over to you. Do you want to point things out? And I'll move? You want to take it?
Yeah, no, it doesn't matter to me.
Sure, go ahead.
So yeah, that's what we use, but that's where it came from. It's super high torque, separate power supply, so you're not just trying to pull 500 milliamps out of it. Right. So the question was, he's asking about some of the controls. We've got a water submersible high torque steering servo that we replace the handlebar cable on the ski with. That's inside. In fact, I'll probably get you a view for everybody on the screen. So we've got a steering servo here. There are all of our boxes in here are orange, just to identify our boxes versus ski boxes. So there's kind of one on each side that you can see, the two batteries, and then you can see our kind of network box up here. This is, we create our own network. The ski has its own network, so all of the sensors are plug and play. If you were to add an external sensor, it would simply plug right into our network with one of these additional network ports. This particular ski here was made for the herd and burn, but we have another one that we've sold that has robotic arms. So these pods simply unplug the cable from here. These are quick disconnect hydraulic cables. So pull this, and this whole pod will come off, and a robotic arm will go on there, or any sensor that you want. So the robotic arm goes on here, plugs into here, and then you can plug it right into the network port. And there's a power port also, 12 volts. I think we give you 10 amps, maybe.
Let's get one conversation going while Tim's speaking. If you're gonna have your own conversation, maybe move away because we're getting noise on the microphone. It's gonna be hard for the Zoom people to hear. So we could keep it down and everybody move in and just ask questions of Tim as we go here. Tim, you want to just maybe you're doing a go around?
Yeah.
Just say that here's the main
Point everything. Yeah. So as I move out of this area, you guys can follow behind me if you want. If you want to look inside and see the control piece, but for those that are on the Zoom call, you can see that we've got the Garmin chart plotter screen here that gives us all of the radar, sonar, map, navigation controls right here on the screen. We can still manually operate the ski from this control panel. We've got a breaker for every single system. There are the main switches, accessory ignition, aux, drone, lights, bimini, the winch in and out. There are two separate fuse boxes, all labeled on each side. So
If there is a problem, this is one hatch that can kind of open and we can see all the breakers and all the fuses at a quick glance. This is one of our boxes that controls a lot of the electronics. A lot of the networking equipment is in this particular box. So this bolts on to the underside of this lid, and you can kind of see some of the labels. We're using a waterproof connector on all of the boxes. Every one of these is water submersible. We had a 2-month test with this particular connector manufacturer of it submersed, and they passed. So we're very happy with these connectors, but this is one of the boxes that we add to the base ski. And then there's another one at the very top. That's really the only 2 boxes that have most of our equipment in it. And you can see everything's just kind of plug and play. We bought extra boxes this week just in case there was a failure. It's real simple to unplug these, bolt the new box on and plug it back in. So knowing that this was kind of a universal sensor platform, we wanted to make any kind of repairs. We don't want you to have to get in there with a multi. Just replace the whole module, send it back to us. We'll send you a brand new one. And just with no tools, you could replace, unplug all of this, pull that off and pull it back on. This one, you see there are 2 cameras up front. That's also where the LiDAR module will go.
Hold on 1 second. I got
Very top. It's what we use for location on the ocean
I
with the
don't
ski.
know.
And all that sits above the Nomad radar, which I had
before,
talked
but
about earlier.
I'm assuming oil cleanup.
There is a cellular engine. I think I mentioned that's also in the box. That's what the 2 big antennas on the side are. We're getting like 4 dB a gain on those antennas. So the range is we've been impressed with the range of the cellular engine. It's a PEP wave or PEP link, if anybody's familiar with any of those. So then walking down, you can see all of the electromechanical actuators. So this, anytime that we travel, whether it be in the trailer or whether it be underslung from a helicopter, this folds down onto the deck. This folds underneath this bar, so everything's kind of protected, and it sits flat over the bottles and everything. We haven't talked a lot about the helicopter drop, but that was one of the requirements that's been asked of us for this particular ski. When this is down, there are 2 bars that are missing. You don't see here. There's another bar that comes off of this section that mimics this angle. So just imagine one here that kind of goes across in front of this box here. I'll close this. And there's one on the back that protects the drone. When all this is folded down, these have 3 big, think of them as pool noodles, but they're roll bar cushions. So there's one that sits here, one that sits on this one, and one that sits on the drone arm. There's a winch, a 3,500-pound winch that bolts to the deck there. You can look inside and see we've got all kinds of, the whole cage, roll cage is mounted to the engine. The engine is the heaviest part of the ski. The cage is mounted to the engine, which is mounted to the hull. But we knew that a lot of helicopters don't have hoist capabilities. Most of them are off to the side. We want to be able to transport this from the ground to the site. So the helicopter either parks next to or is airborne, and our cable hooks onto the hook of a standard helicopter. We've been using as Curtis, he's the helicopter guy. What helicopter? The Black Hawk. Yep, Black Hawk. Once he's in the air, they hook to that. This will winch itself up to the bottom of the helicopter. So the helicopter doesn't have to have any additional equipment. All 3 safety releases of the helicopter remain intact. They've got a pull, they've got an electromechanical, and I think there might even be an explosive bolt. All those are still functional, so we don't change the airworthiness of the craft whatsoever. This gets motorized up under the skids of the helicopter. It's still kind of protected by the skids, and then they can head to the spill site with very low drag. You know, only the bottom of the ski is exposed, and it's a very aerodynamic platform. Once they get out to the spill site, the winch is released, lowering the ski under the water, or if they just pull the plug, it's going to hit the water. Everything's completely submersible. We would expect it that even if it went under the water and porpoise, come back up, and then we start to unfold the radar platform, the communication platform, and such like that. That operator would be done from inside of the helicopter. Once he pulled the mast up and established the communications, he would then hand it over to a command trailer that would be maybe in Alaska or something. then the helicopter can peel away, go back to space, and everything now would be done from the base station in Alaska. Again, I think I mentioned before, we've got the satellite communications, UHF radio, and a VHF radio. This does have its own network, so any radio, you could use an Ubiquiti Wi-Fi and plug it in. We're a military company, so we use a lot of MANA radios. The Trellisware plugs right in there. We've had great luck with Trellisware. Means we can also interface with some of the military operations with this particular ski platform. So moving back through the drone, which I'll show you inside, we didn't use for this particular exercise today. If anybody's a pilot, we've been flying the drone in Oklahoma, and so the regional maps reside on its IMU from Oklahoma. When we come back here, we're having a hard time getting it to load regional maps. It's still not real sure where it's at here in Alaska. We've tried all week. It works, but the GPS is not as accurate as we would want it to be given the small test space here. We're worried that with the tether coming off and it's being in the sky, it might get wrapped up in this. However, on the ocean, the tether, say we're flying at 100 feet, we probably put 150 feet of tether out. So we're dragging the tether in the water, which floats, by the way. And then there's a slack in the line for the drone. As the ski kind of goes up and down, depending on the wave swells, it wouldn't affect the drone whatsoever. So there's an arm that sits here. I can show you the pictures. Well, here's the actual point. There's an arm that goes across here and a garage, and the drone is suspended inside that garage. When we activate it, this motor opens this garage and places the drone, and it's a tray, in the water. This is the spool with the tether, and we start to unspool this as the water drags the drone away. It's floating on the water now. The jet wash from the ski kind of pushes the drone away. We'll pull away maybe 20 feet from the drone and then launch it directly out of the water. We can go to 50 feet, 100 feet. There's really no limit. We have not flown it higher than 100 feet. There's no reason that it couldn't be. Once we're in the air, we just keep reeling this out until we've got what we feel is enough slack that the jet ski wouldn't be yanking on it. Use the drone operations. The drone tether is for power only. There is no data or video over that particular tether. The drone does have its onboard battery, just in case this tether does get cut or sucked into the impeller or severed. The drone would sense that. It switches to onboard battery, and it would just auto land itself after about 10 minutes. You would get a signal if you see the dashboard once we go inside there that we've lost the tether power. However, the drone is still under control, just like it was with or without the tether. You'll see the voltage drop. We can fly it, we can land it, you can bring it to the shore if you needed to and land it from there. And we would just reel the tether back in. So these are the limit switches that tell the arm when to kind of stop. It's fully deployed. That's what stops it from going further. This is what stops it from going any shorter. These are limit switches. Once this cable gets taut, that tells the spool to quit spooling out. There's still some shortages on high voltage power supplies because of the whole COVID supply issue. So we've been having to kind of hand make power supplies. Teledyne, the manufacturer, is the power supply booster that we've been using, and kind of hand build a power supply on the system. But for the demonstration this week, we just had to hand build one and kind of strap it onto the top at the last minute with the gear that we had. So most of this cabling would go away and this would be gone. If you look inside the pods, one of the things that we tried to do was use as many off-the-shelf components as we could. You're out in Alaska, you're in the field, it's hard to get parts. So I'm sure everyone's familiar with, MAP gas nozzle. There's ignition coil in here. Some of the previous tests that had tried to ignite ignition to ignite gel gas were using spark only. And the temperature of the gel gas, the mixture of the gel gas, it's complicated to get that mix just right. So we're using the butane as a booster. We've got this ignition pack off of a Chevy ignition pack. You can get them at O'Reilly's, even here in Fairbanks. Bolts right in, plugs in. This bell here, we've got butane that comes in. There's a solenoid that's hidden in this in the pod here. We shoot butane or MAP gas into this bell housing. There's actually a spark plug in there. I know someone's going to ask, do I see a spark plug in there? There is, off-the-shelf components, and that's what we're using for spark. They work very well in the car at several RPM and last for years. So we're, again, using those components. We ignite the butane with the spark plug from the ignition pack, and then we shoot the gel gas through that. So we've got spark
to the butane creating that nice fire plume, and the gel gas is naturally lighted from there. You can see this is the gel gas nozzle. There's another nozzle right down here. That's our herder deployment nozzle. There's still a lot of experimentation going on there. We are not the experts for herder, how much it takes over what distance and the speed. So these nozzles are replaceable. We can adjust from the computer inside the command center, the volume, the speed. We're just using PWM. We're just kind of pulsing the dots in the water of herder, but we can go from 25%, 50%, 100%. We give that access to the drone commander, but also from the computer, you can dial it in even more resolute than that. So that's kind of the pod section. We told everybody when we got here, this is kind of the flashing red lights. If you see this light flashing, you need to stay away because it's about to get crazy. There's fire coming out of there. So I think that's really most of the systems. What questions you guys have that maybe I could answer? Or did I cover everything so well?
If it rolls,
Yeah.
can it self-right?
So if you want, if you'll send an email maybe to Tim, I'll give you the passwords to our test video site. We've done test and there's a whole YouTube channel set up, but you have to have access. And on one of those is guy taking this and pulling it all the way into the water. It won't completely flip upside down because this acts as a buoy, but all of the weight's at the bottom. So he pulls it and he almost has to push it down and releases it, and it comes right back up very, very quick. Like a weeble wobble, tip over, but they don't fall down. So it does self-right itself. If you wanted low drag, this could certainly be lowered for some of the long range operations. Tanks in here, and you'll see some of this if you get access to the video. There's an orange tank you'll see on each side. Each is a 10-gallon tank. We can configure it in any number of configurations. This one particularly has herder in one of the tanks and then gasoline in the other one. So we've got the factory 8-gallon tank. We've got an additional 10-gallon tank. This could also be used as a reserve tank. If all 3 tanks were filled with fuel, we're 100 miles is what you could get. If you're just loitering and we're floating with the oil maybe and taking a sample in here, you'd have over a week, of loitering before you'd have to get back to it to refuel or charge batteries or anything. Top speed right now from the factory, is probably close to 50 miles an hour. But with a chip change and some engine modifications, you can go faster if you wanted to. I don't think that you need that. But you look in there, you'll see some of the tanks. There is the pump system for the gelled gas that resides in the back here. Whoever's familiar with ski, you'll see the exhaust system. We had to redo the exhaust system. There is the gel gas chamber, and then the pumps, most of the solenoids and such. All of the hydraulic connections are quick disconnect. When we do maintenance on the ski, the top obviously has to be separated from the ski. There are 3 wires here, 2 wires here, and 2 cables. And then this whole ski can come off and set to the side. We actually did that. All the bolts have to come out. Yeah. But we did that out here one side. I know that Scott wanted to look inside, and we had some maintenance we wanted to do in there, but the top came off. So it's and then you can get right in there. You see every component. So in a matter of 5 minutes, the ski can be completely disassembled and parts can be swapped out, and you can diagnose. Great question.
A silly question. Sorry, maybe a silly question, but how flame retardant is the hole itself? Would it see if you come through, burn it up, light it off, and you got residue on it? You potential for
It's called polytech. It's the material that the hole is made of. They use it for several reasons. One of them is it's the ability for flame retardation. Is that a polytech? If you can, I don't with the hull being exposed to the flames. This is a aluminum shell that has a sarin coat on it, rated at 1100 Fahrenheit, 1100 degrees Fahrenheit. So you can see one of the reasons we use the sarin coat is the oil just beads up and washes right off of it. I'm sure, trying to clean booms and other ship hulls that are raw aluminum, it doesn't come off real easy. We've had great luck with this sarin coat, and it just pulls right off. We have tested it, some with some, I haven't taken a torch to it to see how well it does, but I know it's flame retardant.
Polytech is the material, and you can probably get more specs that you're asking.
Yeah. From the Zoom, they were
Yes.
wondering how much area that can be covered with this. What is the maximum size area?
For a herd?
Yeah.
That's probably a question for you. We've got 10 gallons. You know how many liters per mile?
Okay, so the rule of thumb, so it's hard to say how much oil can be treated because it depends on the size. So the rule of thumb for a herder is you need to spray 5 liters per kilometer. So these little slicks, there's a bunch of those little slicks. You have to go around the perimeter, so you'd be limited. But we think, I've done the calculations. I think 1,000 barrels is easy to treat if it's, you know, if it's a large continuous slick, because it's you know, it's a linear thing. It's a lot different than dispersants. My estimates are, again, depending on the size of the slick, that you'd use between 10 and maybe 100 times less herder to treat an oil slick compared to if you were going to disperse the same oil slick.
Okay. Other question from Zoom is what type of pump is used to pump the gel gas?
Yeah, it's a modified pump that we use. I mean, it's 1,500 PSI is what it's capable of. But it's a special hybrid that we've come up with. I don't want to give all my secrets away. You can see that we're probably shooting 40 feet, 30 to 40 feet away from the ski with, this gel gas. The viscosity is different than, anything else that normally goes through these pumps. So that was part of the challenge, and that was a lot of what the R&D went into it. But yeah, you'll see it back there. It's a pretty big pump, and we're capable of that viscous material.
This is all completely like waterproof. It can go under the ocean.
You see, are completely submersible. So our concern was if there was a helicopter drop, it's going to go under the water and just kind of porpoise back up. But no, it can be. I can't give you a sea state rating yet. However, all of the pieces completely sealed up and are completely submersible. Yes. Got to wipe the chin.
I just leave that sitting on the ground, Curtis. Just leave it sitting there. Just let it drop. Yeah, just let it drop on there.
You had a question.
It was about these days.
Okay, there you go. Yeah. We have some tests next month out in the Gulf of Mexico, out off of Galveston. So we're gonna put it through its paces and see what we can get. Really, we don't see it being any different than a regular jet ski. And I know there's a great Discovery show where there's 5 guys take a jet ski and they navigate as an icebreaker and up the rivers and some big oceans, and it performs very well. The fact that it could be completely submersible, some of the challenges are just making sure that the gas tanks are breathable, should it go alongside. We don't want to take on water, but we still need to get oxygen into the hull for the engine. All of those have been worked out. So we are expecting to be impressed with the sea state worthy, but we don't have certification yet, but we will have some of the trials starting next month in Galveston.
Oh, I'm sure this thing could go through a hurricane and it would still be operational in the end. You might not be doing any mission during a hurricane, but it would. There's no you might shut everything in and just let it do its thing, but it would survive anything, right? You might really slow it down in 20-foot seas. I'm not sure you'd be doing much of anything other than maybe one of the kind of, not this version of it, but one of the great capabilities is the other version has a VOC monitor on it. And so we think we'll be able to turn it into a tracking buoy, right? So this thing goes out and finds an oil slick. It goes on kind of low power mode. It'll have a smart algorithm in it that tells the jet ski to stay in the concentrated VOC. And so overnight, when slicks are lost in a spill today, this guy will be where the concentrated VOCs are, and we'll have other instruments on it. So I think it's a smart tracking buoy that will allow faster operations when the daylight comes in the morning. You won't spend hours kind of refining slicks, and the dummy tracking buoys that are out today seem to move with the winds different than the oil does. But this is a smart tracking buoy, and then it can do all the kind of characterization of those oil slicks beyond what a dumb buoy. And then if you wanted to do something active, it has all these other capabilities.
Limitations like temperature and wind speed as well. I don't know if you happen to know those. Yeah.
So I'll tell you that the drone will only has 1 foot of draft. I mean, it's just barely, so very shallow operations, and there's only 2 feet above the water, even if you come. So for us yet, temperature, that was one of the reasons that we chose this particular platform, because this is the same material that they make snowmobiles out of, is this Polytech, and that's the same engine that they put into the snowmobiles. It's also the same one that they use in personal watercraft that are, operating in Cancun. So, Suzuki, Kawasaki, all those personal watercraft manufacturers have done a lot of research to make sure that they're very reliable in extreme weather. So we don't anticipate any problems. They've solved all that for us.
Any issues with the fuel from when it turns to jelly? Normally, like diesel fuel turns to jelly in freezing conditions. Is there anything that we would need to worry about with that?
Yeah, no, what we're finding is because the muffler and everything is still, and there is still water that comes in to circulate throughout the muffler, but we do have elevated temperatures inside that hole. So it keeps the gel gas kind of at a perfect temperature. It also keeps that coolant at kind of a nice temperature. So inside of the hull, we do have temperature monitor. There's temperature sensors in there that you can monitor from the shoreline. But because the inside of the hull, where the gas resides and stuff like that, we haven't seen any of those issues at all. Yeah.
Okay, thank you very much.
Yeah, you bet.
Hey, you might mention I don't know if you mentioned all the camera, the bullet cameras.
And microphones. We can actually almost tell more from sound than we can seeing. We want to hear the RPM of the engine, if there's something clicking or rattling or sloshing. So there's a camera inside that's looking down the what do you call down the middle of the boat?
Keel.
The bride or something. I forget that. Yeah. I'm getting a blank here. So there are 2 underwater cameras facing straight down. When we go inside, you'll see the bottom of the tank because the cameras are still up in there. We have under the hull that's under the engine and everything. And then there are 2 cameras in the front. And then there's this 360 camera that's up here. And we can divide that into as many views as you want. One of our favorites is to put that in 180-degree panoramic because you could put on Oculus and drive, and it's like you're sitting on the jet ski. So you still have your peripheral left and right, still looking forward. In fact, at a trade show, when we take this top off, we think we might take that to the trade show with us. So that's where you sit on and you grab it and put on the Oculus, and you could actually drive it like that. Virtual reality jet ski operations. But we divide the camera up where we have a section of the video is right here. We want to see this to make sure that the herder's coming out, make sure that the flame is initiated, make sure the flame goes out. So each pod has a section of the camera on it. The front is one on it. There's a left and right and the back. But you could split that camera up into 16 different cameras if you wanted to. But there are 4 in the hull, and I know we have the ability to put 16 on the feed. Just know the more cameras you put, you're taking up a lot of bandwidth. We've got some work that we've done on the 4 that we've got where you can bring up primary image for like driving and steering and still have thumbnails of the other cameras that are not, they're at a reduced frame rate and at a reduced resolution, try to conserve bandwidth. But the one you're driving from is full 30 at 1080.
Any other questions? Any questions, Kevin?
Yeah. Can you describe how you monitor for VOCs?
So we purchased an off-the-shelf Honeywell VOC. So it comes in a nice Pelican case. It comes with its own computer, CPU, and everything. There are 8 different nozzles you can put on there for the sensor, and there's a data output port of that Honeywell Pelican case. What we do is basically the Pelican case sits where that power supply is right now and just plugs right into our network. Then we extend the sensor cable up to the mast so that we've got a nice 5-foot elevated platform for all of those VOC sensors to reside. We don't touch the Honeywell at all. That's off the shelf. We don't do anything. It comes as it comes from the manufacturer. All we're doing is remoting the data to Honeywell software on its own computer within the trailer. So, usually it's laptop and sensor. All we're doing is putting our radio in between there, and so they separate and sending that over there. So, We did not make the sensors. That's Honeywell off the shelf. Plug and play. Any other questions, Kevin? So this is, yep, go ahead. So far, so good. This is kind of our R&D drone. Again, trying to use as many off-the-shelf components as we can. This is a proven waterproof drone housing, motors and everything. And then we put all of our components on the inside. It looks kind of normal from the top, but if you look on the bottom, that's where our power supply, that's an aluminum heat sink. We've got our tether that we've added. There's a safety strap for the tensile strength. There is a thermal camera and there's a visible camera. So one of the things that was missing that's very dramatic from this particular test today on the DJI is that thermal camera. It really shows, you know, the oil nicely on the water. So this does have thermal and visible on this drone here. We've been asked on the next ski to have Scott was a pound, maybe a pound and a half or 2 pounds. We're trying to increase the payload so you can put additional sensors on here. Some of the customers have external sensors they just want to put on the drone to get, you know, higher up. So the version that we've got on the drawing board right now has I forget how many pounds, additional pound sensor payload, but that's the guy that's driving that boat. So that is the drone as you see it. There's a master switch on the top that holds the, you know, we had to add some type of battery. One of the interesting aspects of this drone being tethered is we do not have, as I understand it, and this is how it's been explained from the FAA directly, we don't have to follow the same flight safety rules and licenses as an aerial drone because it's tethered. It's considered safe. You know, we still have our Part 103 guy here to fly it, but because it's tethered and we stay under a certain altitude, we believe you don't have to have any other additional license for that to fly. But I think sometimes it depends on which day you're asking for. But we have it in writing from the FAA. We are
Okay.
cleared and
It's
good
the
to
last
fly.
day I heard that it was a different story. So that's good news. That's good news.
Once I got a piece of paper I could point to,
Yeah.
I said, this is what we're going with.
That's good news.
Yeah.
Hey, why don't we do the zoom inside we'll do the trailer, maybe show them the hoist for pulling the jet ski around. We'll go inside the trailer. We'll do that with the zoom and then we can release the zoom people and then we can take people in that are here in waves.
Trailer on and off, or in and out of the trailer. This is kind of our dolly, so we don't have to try to truck it into the trailer. In fact, if it's not rocky like that, this could actually go and release the ski into the water and then we pull it back out. But this is our transport vehicle it'll do up to a 3,000 pound, 3,000 pound trailer. They use it to move airplanes, helicopters and such. But this is a nice, easy way for us to be able to steer the trailer in and out of our transport vehicle. So if you want, we'll kind of take a few people in there and walk through, especially with the zone people. Answer questions about the trailer.
I'm going to do a walk around the trailer for the Zoom people, and then I'll meet you at the door. So this is, this is a good kind of car toy, or our remote vehicle RV toy. This door comes down, so it's a ramp, and that's how the jet ski goes back on the trailer. It's got a satellite dome on it for now next to the generator. So it's satellite dome. It's got a heating and air conditioning system. So it is the storage center and transport for the jet ski. And so I'll get Tim back over here to explain the inside, but we're going to go to the inside. You can see it's got a pretty neat setup. He's got these blue lights and we can change the lighting. Get these monitors. So there's 4 monitors in there to allow you to do all the controls. I'll let Tim take over here.
Watch your head. So this is our command center. We've got these tables. It seems like everybody was working on their laptops and tablets and notebooks. So 2 tables here. This is how you would drive it from the command center. This is throttle. If you look on the sticker, this is where the herder and the fire and start, stop, communications would be. Steering, it is force feedback. So if you hit something, it'll stop and let you know that you're hitting something. This is the dashboard of the ski where we can look at all of the different temperatures, the different voltages, levels of coolant, levels of herder, levels of gel gas. These are icons. When a door opens, we get to see it open on the door. We get to see that. Here's that drone where I was telling you about that folds out. So we get to look at, here's where you set the herder. You want 25, 50, 75, or 100%. Which doors to open, the controls on the bimini, emergency kill, startup ignition, lights, the helicopter winches here. This is our drone, and whether it says we've got GPS and how high we are and such. This is the mix section. We won't get into that. But those are the camera dashboards there. If you look on the bottom, you'll see the underwater cameras kind of picking up some of the topography of the floor of the test basin. This was our last test that we did yesterday. That's just sitting on somebody's lap. That's why you see the gene pattern of thermal there. That looks like the last picture we took before we shut it off coming back from the test. No signal there. And then there's a split screen of the 360 that's kind of looking forward, back, and then left and right. The last one there at the autopilot kind of shows the map. It shows our GPS. You can kind of see that drawn out there. Yep. That's where you can set waypoints, drive to here, drive to there on the spill, and that's where it'll monitor and stay. All of the autopilot controls will be done and configured from that particular window there. The front of the trailer, all of the breakers and fuses are up in that top section. Again, trying to just make it real easy out in the field. I don't want to get calls in the middle of the night from everybody. How does this work? You pop that out. All the fuses are there, breakers there. AC breaker gives you what you're drawing, how many circuits you've got. Backup power supplies for the computers. We've got rugged 12-volt computers over here to the right, all of your charging stations. And then there's a toolbox underneath there. So any tool that you need, it comes in the trailer. Anything that you would need to take apart, you got all the tools that you need. These come out. We store these underneath. And then the jet ski comes in and kind of just sits right here where all of these chairs are. These fold down and the ski's in here, and it's a self-contained, command center. The door opens and closes, and then we, put in these pretty lights to impress you guys. So that's kind of it on the command center. Any questions or suggestions or observations? I'm open to suggestions if people think see a better way to do it.
Yeah, I think we're for the Zoom people. I think if there's any more questions, you should ask them now, because I think we've shown you everything. As far as the test, as far as the system, as far as the command center and everything else. So not much else to see, but if there's questions, you need to ask them now, or you can anybody can send me an email and we'll get them answered. But if there's any questions on Zoom, post them now. And if not, we'll let the Zoom folks go about their business.
Tim,
Anything?
Nancy Kenner here. Nancy Kenner, it was great.
Awesome. Perfect. Thank you. Oh, I'm hearing them in my hearing aids. I'm connected to the audio of the Zoom call, my hearing aids.
Oh, you're hearing people ask questions?
I just heard them saying, she said it was great.
Oh, great.
Glad people like it.
I don't have any sound on this.
The back. Perfect. Yeah, you don't have audio.
We're good, Kevin? Okay. Well, listen, we're going to sign off on the Zoom. I think we've kept you long enough, but we appreciate it. How many people did we have, Kevin? I saw over 100. I saw over 100. Yeah, I saw over 130. So thanks everybody. Thanks everybody for tuning in. And
hey guys,
knock
great
on wood.
job.
I guess we don't need to
Thanks.
do that now, but we really had a great demonstration here, and that's kudos to the tactical team and Tim and everyone else. That this is a pretty complex operation. We got a lot of moving parts. So, but anyway, thanks everyone for tuning in.